On this slideshow, we're going to talk about a couple different HVAC systems and their parts, as well as look at some of the common pieces. On this slide, we see a common HVAC setup for a larger building. This is a chiller and a cooling tower setup. The cooling tower is on top of the building, usually, or maybe beside the building. If you go into Northridge ACC, kind of by the north side of Building 1000, you'll see they actually have a cooling tower, or a couple cooling towers there. It takes the water that's been warmed, run through the chiller, and it bleeds off the heat. It runs it through essentially like a radiator coil, and that'll cool the water, and then goes back to the chiller. So this is really an enclosed system between the chiller and the cooling tower, connected through pipes, and the water goes between the cooling tower and the chiller. And then from there, the chiller has pipes running water to the air handler units individually. This is where air runs over the pipes with the cool water and creates cool air. From there, it goes out to the terminal units and the diffusers. Next is called a packaged rooftop unit system. So this will be used in medium and smaller size commercial buildings. This is essentially all one big unit intake, everything all in one. So remember we talked about the return air and the supply air. So the return air, this is pulling the conditioned air in from above the plenum to reuse the package unit. Package unit pulls in outside air and mixes, so it doesn't mixes with the return air, so it doesn't have to work as hard. And then from there, it goes out into your ductwork, into your fan power terminal units and your VAVs. Next, we have a split system. So this is a heat pump. A lot of times you'd see this in like server rooms, or you could even have one in your garage, or some houses, some places use these instead of the systems that we use. Just a few of them, one in each room. Essentially, there's a condenser unit, so this would be on either the roof or the outside, and then there's pipes running the cool refrigerant to an evaporator coil, which pulls in air, runs across the cold pipes, and then pushes the cold air out. Next, we have a VRF system. So VRF systems are kind of like the split system. In fact, that it has the one VRF condenser outside, then it goes to multiple cassettes, and basically you'll have hot and superheated or super cooled gases running through here into a selector, and then to your units here, which essentially make the cold air pull air out of the plenum and then blow it back into the space. Next, we have FPTs, VAVs, primary and secondary duct. So this picture, the primary duct is this big long trunk running around. Remember that the example set that I showed you earlier? It had a trunk that ran around the entire inside the entire core of the building. So that's your primary duct. Your secondary duct is going to be all of this duct going. So there's a duct going in here to this room. There's ducts, going out over here, going to blow cold air into this window zone. And then you have your fan power terminals, which are your FPTs, and your variable air valves, which are VAVs, basically controlling how much air is being pushed out to these secondary ducts. Next, we have an outside air damper. So here we have a automatic, this is being controlled, pulling in outside air. Usually it would be a fan up here, and it's pushing outside air, and then this will close off depending on how much outside air you need. Next is exhaust fans. Exhaust fans, if you think about it, in a commercial bathroom, you don't have a secondary switch like you do in your bathroom to turn on an exhaust fan. Basically always on, always pulling a slight amount of air out to recirculate the air. So this is basically what's up at the top on the roof, and this goes down and being fed into multiple restrooms. Next, we have a pressure tap. Pressure tap is this angled piece of duct right here, and there's one on this side too. So essentially, air. You kind of think about air as almost like a fluid, right? So air can get turbulent. It can depending on the level of corners and whatnot, like there's pressure in there. So the pressure tap essentially will make it easier for the air to go around these corners. Next is a fan power terminal unit, or FPT. So that is this box here. This is on the secondary part of the ductwork. So in this picture, you'd have your primary ductwork on this side, and then you'd have different offshoots of secondary duct with this fan power terminal unit on it. And what's going on in here is there's actually a fan in here. So this is connected to a thermostat. It tells the fan, "Hey, I need to turn on to supply air into this area," and it will pull air off your primary duct. Um, and these boxes can have heat, so it can have an electric or gas heating coil that can bring in air and add additional heating if needed. Next is the variable air valve or volume, uh, and basically that is it does the same thing as the fan power terminal here, except it doesn't have a fan. It just has a valve in there that it can open and close on an actuator. So a thermostat is connected to this, and it tells the unit, "Hey, I need more air," so it'll open up the valve and release more air. And then whenever the temperature is satisfied, it'll tell it to close, and it'll close up, cutting off the air. Next, we have return air transfer and open ceiling diffusers. So these are return air transfers. Remember, we talked about the fire rated walls. So this wall goes all the way to the deck, which is the floor above. And basically, they need a way to get the return air back to an air handler unit. So say there's a big mechanical room on the other side of this wall. This will allow air to jump over this wall that's all the way to deck. And then you have your return air, or sorry, now you have the open ceiling diffusers. So that is this guy right here. So there's your supply air comes out of this duct, and this would be in like an open ceiling application. There's not. It's just going to be open, and these are just dumping air out. To satisfy need until a thermostat tells them to stop. Next is linear slot diffusers with return air openings. So that is, these are connected to ducts on probably this side here. This opening here, it would just go into the plenum, so air can basically get sucked into the plenum and go to the return air input from your unit. This is a square diffuser. So this will be where your supply air comes out of. So there's a duct above here feeding into this, and this duct's, this will be a square diffuser. So this could be a supply or return or exhaust. Basically, just a diffuser and a lay-in ceiling. Usually 2x2 is kind of your typical size for these, and yeah, they can be multiple systems: supply, return, or exhaust. So this is a picture of the split system we talked about, which is the fan coil unit and the condenser unit. So this would be on top of the building or outside, and this would be in an area where you need spot cooling. Like if in a electrical room where there's transformers create a lot of heat, and so this will basically keep everything from getting too hot. Or in a server room where they have a bunch of servers in a rack, they can cool the area more efficiently. Here's a picture of the rooftop unit we saw earlier. This is just one complete enclosed unit that has your return air, your heat, your cooling, everything, just on this unit that'll be on a rooftop.